This is an intro to applying the concepts of area and circumference to something a little bit different as a part of our circle, a portion of our circle. So, if you can find the area, you can find half the area or fourth of the area. A lot of times they're not always so nice and neat. And so we're talking about a fraction of the area, and that's called a sector. Okay, and it's a section of the circle. This would be a sector. This sector is a diameter, so this sector is a lot easier to figure out. If you had to figure out the area of this circle, you would just do pi r squared, and r is 6. So pi times 6 squared is 113.1. That means the area of this sector would be half of that. 56.5-ish. Okay, that means approximately 56.5. Okay, what do we do though when it's not a nice fraction like a half or a fourth? Well, if you think about a circle, there are 360 degrees in a circle, and we need to know what fraction of our circle is our sector. And so 70 out of 360 is our fraction of our circle. And when we say of our circle, we're saying of the area of our circle. So for this problem, it would be 70 out of 360 times pi times 3.2 squared. So it's a pretty straightforward formula. Make sure you know how to enter that in your calculator. If you have parentheses, use them and go 70 divided by 360 times pi times 3.2 squared. You can do it all in one step if you use the parentheses right. So that sector would be 6.25. Well, 6.26 inches squared. Because the entire circle is pi times 3.2 squared, which is 32. So it's a fraction of that circle. The same thing would have worked down here. This is half a circle because 180 out of 360, it reduces to a half. Okay, so the area of a sector has a formula, and it's right here. So this is all in the back of your page. I'm adding some stuff to it. Number of degrees out of 360 times pi r squared. But just understand you're taking a fraction of the area. That's all that is. Okay, and the other thing we want to find sometimes is length of an arc, and an arc is part of a circle. So that is related to the circumference. I could find the whole circumference here. Circumference equals pi d. So if the radius is 4.9, then the circumference equals pi times 9.8 because we double that. And so I can find the whole circumference. 9.8 pi is 30.79. We want the fraction of the circle that's right here, which is 150 out of 360, because it's 150 3/60ths of a circle, times the circumference. So times pi times 9.8. We already did that. That pi times 9.8 is 30.79. So I'm going to do 150 out of 360 times 30.79. You could also do the 9, which is 12.83. And that is this length right here of that arc. It's the distance if you had to walk around there. Because the whole circle is about 30. It's not quite a third of the circle. It's a little bit bigger than a third of the circle, but it's not quite an exact number. Down here, the fraction will work out perfectly. We just take, basically, you'd find the circumference and take half of it. Half circumference. The reason that works, 180 out of 360 times circumference is the same as half times circumference. So kind of straightforward. If you understand circumference and area, the sectors and arcs are not bad. Okay, so the formula for the area of a sector n over 360 times pi r squared. Ignore that business. So n over 360 times pi r squared. The formula for the length of an arc is n over 360 times 2 pi r, or n over 360 times pi d. Those are both the same formula. You may want to add that up to the sector along with the rest of your notes. We didn't have that on the front side. You'll be getting your formula sheet. For right now, you just got to write these formulas down and use them. So there's your length, and there's the area. And that will help you finish that worksheet that we started on 4.1 that had the difficult area problems.